Hello. So, in our past sessions, we have understood what is mechanism. Now, mechanism is assemblage of rigid bodies which are called as links joined together with movable joints and to achieve desired motion. Now, we are forming a kinematic chain and we are fixing one of the, in case of mechanism, that also we have understood, the moment we fix one of the links of a kinematic chain or select it as a frame, it becomes a mechanism. Now, there is another term which is very much of concern for the analysis or design of a mechanism is the degree of freedom, which is also called as the mobility of the mechanism. Now, what exactly mobility is? So, mobility. So, what is mobility? Mobility, we can say, it is the number of input, okay, I'll write input parameters, definitely which are pair variables. I'll talk about this, pair variables that must be controlled independently in order to bring the mechanism, or we can say device, into a particular configuration, or you can say that a particular position. We'll elaborate this one. We'll try to understand this one. So what does it say? That it is the number of input parameters, right? Now, input parameter, we are talking about mechanism. What is mechanism meant for? It is meant for transferring or transformation of motion. So output is a motion, input definitely is motion. That means what we are talking about here, input parameter is definitely we are talking about motion, right? These are the independent motion which we will be giving as an input to achieve a certain required output or desired motion, right? Let us take this simple example of a 4-bar chain or a 4-bar mechanism. So link number 1, link number 2, link number 3 and link number 4. So this is forming a kinematic chain. Now when it will become a mechanism? When I will fix one of the links of this 4-bar chain as the frame. So say this is link number 1, this is link number 2, this is link number 3 and this is link number 4. And I select link number 1 as frame, say for example. So I fix it. Now what is happening here? The moment I select 1 as the frame, the absolute motion of link number 1 is 0. So absolute motion is 0. But definitely 1 will be having a relative motion with respect to all the other 3. Right? And these are supposed to be movable. These links can, their absolute motion is not 0. Now say I select this link number 2 as the input link. So what I can do is I can provide an input motion. Now here see, I have shown these joints as simple circles, small circles. This indicates that this is symbol for revolute pair. What is a revolute pair? Say if you see our finger, these are the revolute pairs. See, when I am turning it, this link can have only rotary motion with respect to this link, right? So it cannot move in this direction. So it is a revolute motion. Fine. So all these are revolute pairs, revolute joints. Fine. So my intentions are, let us say when I turn it by theta, so when I turn it by theta, the output link must turn by say some 5 degrees. So this is the input motion, and when I turn it by theta, I want this output motion to be as some angle phi. This is my desire, this is my requirement. Now if we try to understand this mechanism, so the moment I turn this link number 2, what will happen? Now if I name this as joint A, this as joint B, this I have earlier also explained, let us go through again. Now think about the joint A. When I turn the link number 2, the path of joint A will be this arc. Similarly, the path of B will be this arc. So my desire is, say when I turn this link number 2 by an angle theta, so this I have turned by angle theta. The moment I turn this, so this is going to push this link number 3. So the moment we push the link number 3, B will start moving about this locus, or this will be the path. Now I want to control it in such a fashion that it turns. So if I take this distance and I place it, it should be such that I get this output motion to be as phi. This is my desire. Now have a look at this particular mechanism. So this is configuration 1 and this is configuration 2. So see what is it is saying, number of input parameters that must be controlled in. So I can control in this input motion by theta. So when I am turning it theta, then only it will turn by phi. If I turn it by some other angle, say theta 1, it will turn by some other angle theta 2. Right? So I can independently control. And what is happening in case of this 4-bar mechanism, the moment I turn link 2, all these members are going to execute certain motion, or they are going to receive certain motion. Right? So to achieve phi, I need only one input motion. Now whatever this input motion is called as, or this input I am providing, this is the, so how many independent motion I need? Only one. So I'll say that the mobility of this is 1. Now similar example I have quoted, another example, say a link or a chain with say 5 links. So this is link number 1, this is link number 2, this is link number 3, this is link number 4, and this is link number 5. So now what I do in this case, again I fix link number 1. So the moment I fix link number 1, so what is happening? The absolute motion of 1 is 0. Now look here what is happening. The moment I turn link number 2, so this joint, so here again if I call this as P, so P will be having this path. So I turn it by theta, so it has to taken a position, let us say P1. So it is going to push link number 3. Now what will be the path of joint say Q? It is unpredictable. Now if this joint moves about this, then the path of this will be something like this. But there are chances that there is no motion between 4 and 5. So in that case the path of Q will be something like this. Right? So it becomes unpredictable. See, we have talked about kinematic chain and non-kinematic chain. But if in case I have a mechanism wherein I need 5 links, so there I have to ensure that when I turn this by say theta, I want this to turn by phi. But I cannot control this output with the help of only one input. So maybe in that case I need to provide say maybe another input which is independently, which has to be incorporated in the system. So I need input number 1, I need input number 2. So in this case then only it will become as a kinematic chain, right? So in this case, if you say in this case now I need 2 independent motions required, two independent motions required to achieve the required particular configuration. So in this case, I'll say that the degree of freedom or mobility of this chain or this mechanism to be 2 and mobility of this mechanism to be as 1. So what is there in case of analysis? What first we need to determine is the mobility of the mechanism, right? And we can very well determine the mobility of the mechanism with the help of two things. One is the count of links involved in the mechanism, that means the number of links involved in the mechanism, and second is what we need is the count of or the number of joints in the mechanism with particular degree of freedom. See, why this is important is we know every joint is going to impose certain restrictions. So obviously what is happening is when all the joints are imposing certain constraints, or if all the joints are having certain degree of freedom, then definitely a mechanism will be having a particular degree of freedom, and it will be definitely dependent on the degrees of freedom of each and every joints involved in that mechanism. So how do we determine then? So as we have understood, to determine, but first we will try to understand what is happening in this case, or how we are determining the mobility, expression for mobility. Now just let us say in a space, if I see the coordinate system x, y and this is z, right? Now there is a link in the space. So let us say this is a link in the space x, y and z depth. So this can move along the z-axis, along the y-axis, along the x-axis. It can turn about the x-axis, it can turn about the y-axis, and it can turn about the z-axis. So if this is say one link which is in the space, so it can have three linear motions in the xyz direction, along the xyz direction, and this can have rotary motions about xyz direction. That means three linear, three rotational. So how many degrees of freedom maximum possible are? 6. Fine. So now we are talking about mechanism, and a mechanism will definitely have more than one number of links. So it is a kinematic chain, right? So a chain will be a number of links involved. So let us say there are n number of links in the number of links in a mechanism. Now when we call a kinematic chain as a mechanism, when we fix one of the links, right? That means one link will have absolute motion as 0. That means that link which we have taken as frame will not have any motion in the coordinate system, neither it will move with xyz direction or it will rotate, because its absolute motion is 0. So that means only n-1 links can move in the space, and if one link can have maximum 6 degree of freedom, then n-1 links will have maximum possible 6 degrees of freedom, right? So then what is the next thing? How again we can say is, the moment I form a joint, it is going to impose restrictions, right? It is going to impose restrictions. So that means, see how I can predict the movement. See, if I ask you that in a room you have to say you have a possibility of moving to the moment you enter the door, you have a possibility to turn to left, you have a possibility to turn to right, and you have a possibility to move straight. But the moment I restrict your movement to left and right, you can move only in the forward direction. That means your maximum possibilities were 3, and I have restricted, or I have provided 2 constraints, right? So moving to left and right. So that is why you are moving only in the forward direction, having degree of freedom. So maximum you had 3 degree of freedom minus the number of constraint I given. So now you have degree. So that means out of maximum possible degree of freedom, if I deduct the number of constraints, I'll get your condition of degree of freedom or the mobility. So what we are looking for? The expression for mobility, right? So now in a mechanism, now we will, a mechanism will be made up of a kinematic chain is made up of pairs, right? And pairs are made up of joints. And these, so let us say I call the number of joints as J. I call the number of joints as J. Now, in a mechanism or in a kinematic chain, there can be a joint which can have 1 degree of freedom. So suffix I am giving by 1. So J1 is the number of joints in the mechanism which are having 1 degree of freedom. Similarly, there can be joints with number of joints with 2 degree of freedom. There can be joints with 3 degree of freedom, and so on. And there can be joints with 6 degree of. Now, will it be possible to have 6 degree of freedom? The moment I say a joint is having 6 degree of freedom, that means it is free to move in space, which is not possible in case of a link which is involved in a joint. So maximum there can be a joint, possibility of a joint which can have 5 degree of freedom in that kinematic chain, right? So J1, J2, J3, these are the number of joints with, the J1 is the number of joints with 1 degree of freedom, J2 is number of joints with 2 degree of freedom, and so on. Now have a look here. What did I say? The maximum possible mobility or degree of freedom minus the constraints. If I say I get the degree of freedom of the mechanism. Now, so minus, now there are number of joints which are having 1 degree of freedom. So if 1 degree of freedom, I say how many constraints it is giving? It will be giving 5 constraints. That means, that is why it can have only 1 freedom to move. That means it is 5 times J1. Now there can be joints which are having 2 degree of freedom, right? 2 degree of freedom, the moment I say, then it can have, or it can provide maximum 4 constraints. So 4 times J2 minus number of joints with 3 degree of freedom. If it is 3 degree of freedoms, then it will impose 3 constraints minus then number of joints with 4 degree of freedom. So that means it is going to give a constraint of 2 and J5. So it is going to give number of constraints 1. It has freedom to move in 5 direction. That means it will have only 1 constraint. So that is how I can find out. So for, or in a given mechanism, I will first count for how many links involved in there. So n I can count for 1, 2, 3, 4 and so on. That will be total number of links involved in the system. Then I will inspect the joints involved in the mechanism, and as well I'll try to inspect the degree of freedom. Looking into the type of joint, I'll try to understand what is the degree of freedom of that particular joint, and I'll count those joints as J1, J2, J3, and when I put this in this expression, I can determine what is the mobility of the mechanism. Fine. Now the thing is that most of the mechanisms what we are using, they are planar mechanisms. Now what are planar mechanisms? Just in short I'll say planar mechanisms are the mechanisms wherein if you select any point on that mechanism and you trace the locus of that point, you will see that the locus will be lying on a single plane, or the movement of every link in that mechanism will be on the planes which are parallel to each other. Right? Such mechanisms are called as the planar mechanisms. So if I say planar mechanisms, then my coordinate system will become a planar coordinate system. Fine. So say it will be having only x and y. So I am talking about xy plane or the plane of this board. Now let us say there is a link which is in this plane. Now in this plane this link can move in the x direction, in this plane the link can move in the y direction, and the third, this link can rotate on this plane. So if I say this is a link, so it can have x motion, it can have y motion, and it can have rotary motion. Right? So what is the maximum possible degree of freedom of a link in plane? It will be 3. So this is the maximum possible. Right? Now again we'll move with the same concept. Now if it is a mechanism, then number of links will be involved, out of which one link will be definitely fixed. Right? So which can be called as the frame. Fine. So let us say now in my given mechanism, planar given mechanism, there are n number of links, out of which one is frame. So n minus 1 links can move in the plane, and they can have maximum 3 degree of freedom. Right? Now when I am talking about a planar mechanism, in that mechanism there can be joints which are having 1 degree of freedom, there can be joints having 2 degree of freedom, and if I say joints with 3 degree of freedom, if I say 3 degree of freedom, that means it is detached. So there is no chance of having a joint with 3 degree of freedom. Right? And how many constraints it will impose? This will impose the joints with 1 degree of constraint will impose 2 restrictions. Joints with 2 degree of freedom will impose 1 restriction. So that means it will be J1. How many constraints? It will provide 2 constraints. And there will be joints with 2 degree of freedom. How many constraints it will impose? Only 1. So this will be 1. So I can say that the mobility expression for this planar mechanism as 3n minus 1 minus twice of J1 minus J2 will give me the degree of freedom or the mobility of the planar mechanism. And these criteria, if you see in the space, this is called as the Kutzbach criteria, and in the planar conditions, or this expression is also called as the Gribler's criteria. Now we will elaborately more talk on the Gribler's criteria in the next session. So that is all in this session.